Hey there, this is Dirk. I'm going to be explaining the implementation of the Axelrod tournament that myself and my partner Dono wrote for the Matchbox Hackathon. So it's a system for registering and playing iterative Prisoner's Dilemma tournaments on Starknet. If you aren't familiar with the Prisoner's Dilemma, I'm not going to go over all of the details, but effectively, it's a game where you can choose to either cooperate with the person you're playing with, or you can defect, and you get awarded points based on the outcome of your playing partner's decisions. So it's basically a game theory game, and there's a couple different some flexible ways to do the scoring, but in the end, that's sort of the gist of it. Right now, our implementation does not have a front end, but we're working on building one out to make it all pretty and being able to make it so you can just click and register strategies and run tournaments and all that fun stuff. We built this with Protostar mainly as our Cairo tooling, and Protostar is awesome, and you can write all your tests directly in Cairo, and it's really fast and cool development tool. So on the screen you can see sort of the architecture. So there's the strategy manager contract, which manages all the strategies that are registered, and it allows people to create tournaments, play implemented strategies for other strategies, and also register strategies. So at its core, what a strategy is it's any contract that it can implement the iPlayer strategy interface. And what that is it's just a function signature. Let me see if I can just find it really quick. An example really quick in the GitHub. Let's just get like the defector one. So this is a super simple strategy that just defects every time, but any strategy, player strategy, will just implement this function signature called execute strategy, which takes in four parameters. The length of you take in the length of the array in Cairo, but basically the previous moves, which is just every move that has been happened up to this point in the tournament, so you can base your decisions off previous moves. What move number you're on, and then what player perspective you're playing from in the eyes of the contract. So you will either be player one or player two, and then what happens when you play against each other is the strategy manager will call out to both of those contracts. So let me just find this really quick. So it'll just right here. It'll just call out basically to strategy one, and get the move back, and then call out to player two's strategy contract and get the move back, and then it will compare them and do the scoring. And the tournaments are iterative, so you can register a bunch of different strategies, and then they all play versus each other, and then records the points and registers the points and all that. Or you can just play, just simulate basically one versus one with any types of scoring tables you want. So really, that's more or less the summary. So like I said, you can do one round just to see how it would go. You can just do a play verse, which doesn't write to storage. It just basically simulates two strategies versus each other if you know both of the addresses. Or the meat of it is you can register a tournament and then have a bunch of people register their own strategy, and then whenever you're ready to stop taking registrations, you can call this play function, which can only be called by the person who registered or created the tournament in the first place. And then what will happen is it will play every strategy against every other strategy and record the scores. And that's really what we were aiming for here, and what we're going to try to work out with the front end. And then, that is it. And then the GitHub as well has some example strategies. So the cooperator and the defector are really basic. They just do the same thing every time. And then we have a tit for tat strategy, which is sort of famous in the Axelrod world as being like a very high performing strategy, where basically what it does is it cooperates on the first move, and then on the next series of moves, it will do what your opponent did in the previous round, and it's called tit for tat. And then there's also something that Dono built, which is really cool, which is a template for finite state machine strategies, where it will execute a strategy based on what the state of the game was in the previous round, I believe. I'm actually not totally expert on these types of strategies, but they look cool and they seem to perform quite well in testing. So we'd like everyone, once if we can get a front end off the ground, maybe we'll run a full-blown Axelrod tournament on Starknet, which would be really cool, have people register their own strategies. So yeah, I had a lot of fun building this, and we still have a few things to build out on, but that is it. If you have any questions, you can just message me on Discord, or just open up a issue or comment in the GitHub. Thanks.